Hey everybody, it's Craig Maynard again, first senior mentor for First Robotics, working out of Calgary. And today I want to talk to you about the meeting we had, first meeting we had for our robot build in 3 days, or 3-day robot build. And we had this immediately after the reveal of this year's contest, Deep Space. It looks like a great contest. I'm really excited. There's so many ways of solving these problems, and it's such an interesting event that I know you guys are going to have a fun time putting together your robots. Now, and when I taught and worked in designing automated systems for factories or other projects and things like that, one of the biggest problems we had was information overload. There's so many different ways you can go. There's so many different directions you can take off into. And one of the most important things we do when we start in any big project like yours is to make sure that we know what the objectives are and work toward those objectives. So we got to figure out what things our robot is going to do. Now, there's a million objectives you can have for your machine. You could have a machine that's tightly engineered, really well built. It's just a stunning engineering design. Maybe you're going after the engineering award, but who cares about winning other awards? If that's the case, that's good. Your objectives in your robot might be you wanted to have a robot that was beautiful, very aesthetically pleasing, joy to the eye. No, if that's what your goal is, that's good too. Now, our objectives are probably going to be, we want to build a robot that is going to win. We want to make sure that our points are as large as possible. And it's wonderful with a robotics contest like this because the points and the objectives are pretty clear. They're laid out in the rules and we know exactly what they are. So we can run straight from those. Now, as we did designs as my students did designs in their projects, they would use a textbook, I'd say, that we really enjoyed. It's right here. This is Nigel Cross's textbook. It's called Engineering Design Methods, Strategies for Product Design, and he goes through all the ways that you would be able to harden up a beautiful engineering design, just like you guys are going to do. And one of the things that they talked about doing in here was weighted objectives. That is, what are the objectives of our product and how important are they? How important are each objectives? And of course, we want to focus on those objectives that are important. So in this case, we're going to talk about weighted objectives, and I've got a little spreadsheet drawn up, and this is the spreadsheet that we went and worked on. We had about 20 people there, and we started looking at the various aspects of the robot contest. The first thing we looked at was there's a description. What points are we going to be working at? The difficulty of getting those points. We said that 1 was very hard, very difficult to do. And 5 would be very easy. Then we looked at the time it takes. You have a limited period of time to work with. So if it didn't take much time, you put a 1. If it did take a lot of time, which is bad, you haven't got much, you gave it a 1. If it didn't take much time, you gave it a 5. Now, this is the score for each time you did this thing. Now, it's just a straight number. The repeatability is how many times you expect to score. I mean, for instance, you might put a lot of cargo in there several times, so your score would be multiplied by the repeatability. So score times repeatability gives you how many points you're getting at the end of the game. The weight is simply the difficulty times the time times the points, and it gives you a number. The larger the number is, the more desirable it is. The more you want to be able to build your robot to meet those particular goals. So it's very important we can get the weighted objectives. These are objectives, and this is going to be the weighting. Now, you can play around with these difficulty levels if you want to scale things up or down. It's up to you guys, but it gets you to think about what your objectives are without even thinking about the robot. You're not thinking about a mechanical design at this time. You're thinking of is what's your target? So let me have a look at what we did in our group. Just bring this back up. We looked at leaving the landing zone. You can see right here, leaving the landing zone was the first score point. We thought it would be very easy to leave the landing zone. You drive off, clunk. All right. We said it wouldn't take long, so it's probably 5. It gives you 3 points, and I hope these numbers are all accurate. We were sort of pulling